Here's another example for Chapter 7. So it says that the relationship between age and price of a used Toyota Corolla is given in the table on the right. We want to describe the association in terms of strength, direction, and form. So the first thing we want to do is, just because we know we're going to go further with this, let's decide our explanatory and response variable. So in this case, age is going to be what's given, and it's going to be price that we're trying to predict. So we're going to let this be our L1. So this will be our explanatory variable, and this is going to be L2, our response variable. So we're going to put these into L1 and L2 and take a look at the scatter plot. So again, stat edit to put into L1 and L2. You're going to go to stat plot, make sure it's on, and then you have scatter plot with L1 and L2, and then go to zoom 9. And there's our scatter plot. So this looks very good. It's linear, it's negative. It looks strong for sure. The points are close together, and I don't see any major outliers. Part B says, is it appropriate to find a correlation coefficient and linear model for this data? So this is where we're checking the conditions. And we would say yes. The variables are quantitative. The form is linear. It's not even reasonably linear. This is very linear, and there are no outliers. Okay, so the conditions have been met. Let's find the correlation coefficient and the linear model. And remember that we find this all in the same place. We go to Stat, Calc, and choose number 4. And as long as you have your explanatory variable in L1 and your response variable in L2, you shouldn't have to change this at all. So go down to calculate, and here's the output. So our correlation coefficient is negative 0.97. It's a very strong negative linear correlation. And the model is going to be, here let's use, we'll say price. So we'll say P hat equals negative 959.05 times the age plus 14,285.95. We're talking about the price of a car, so it kind of makes sense to round to 2 decimal places here. All right, so using that, and I used y and x here, but what I just did there was I said price equals this times age. But it doesn't matter. If you want to use x and y, that's fine. So let's interpret the y-intercept in the context of this problem. So the y-intercept, remember, is the constant. It's where the age, in this case, because it's the explanatory variable, it's where the age equals 0. So when the age is 0, it means the car is brand new. So basically this is saying that when the car is new, the price is 14,285.95. And this seems perfectly reasonable. It definitely makes sense in the context of the problem. And just going back, we're not really doing any extrapolation here because our data started at 1, so going to 0 is not unreasonable. Interpret the slope of the problem. So the slope here is negative 959.02, and I'm going to write that over 1. And this is the change in the price over the change in the age, right? The change in y over change in x. So we would say on average, for every 1 year increase in the age of the car, the price decreases, right? We have a negative relationship here. So the price decreases by 959.02. Because I'm writing the word decreases, I'm not including a negative sign on this. Part F. If you want to sell a 7-year-old used Corolla, what price seems appropriate? So in this case, we're going to use the model, and we know that the age, A, is 7. So then an appropriate price, P hat, would be negative 959.05 times 7 plus 14,285.95. And that gives us, oh, lost it here. There we go. 7572.60. Part G. You see a for sale sign on a 10-year-old Corolla stating the asking price is $3,500. What's the residual? So notice that in this case, they're giving us the observed price, right? That's what we're seeing in the real world when the age is 10. So when the age is 10, we're seeing an observed price of $3,500. When the age is 10, what's the predicted price? Well, that we're going to plug into the model. And you'll get 4695.45, which means that the residual, remember, it's always the observed minus the predicted. So it's going to be 3,500 minus 4695.45, which will give us negative 1195.45. It didn't ask us to interpret this residual, so that's why I'm just stopping here. Part H says you have the chance to buy one of 2 cars. They're about the same age and appear to be in equally good condition. Would you rather buy the one with a positive residual or one with a negative residual? So remember, if it's a positive residual, then the observed value is above the predicted value, right? The point is above the line. So that would mean that you're paying more than what's predicted. Whereas if you have a negative residual, then you're paying less than what's predicted. What was observed is smaller than what was predicted, which is what happened in G. So I would want to buy the car with a negative residual, because the actual price is lower than the predicted price.